Ever wondered if there's a cosmic cheat code to understanding reality? A way to unlock the secrets of existence and grasp the mechanics of the universe itself? That's the case with one of the hardest problems in physics, one that has puzzled scientists for generations. What is the true nature of the universe? Does it have an edge? Is it infinite? And if it's infinite, what does that even mean? The answers to these questions might sound like the stuff of science fiction, but they're rooted in some of the most rigorous science humanity has ever produced. The bad news? Solving these mysteries might leave us more unsettled than ever before. Let's start with the basics. The universe is expanding. That's not news. In fact, it's been expanding ever since the Big Bang, some 13.8 billion years ago. But here's where it gets tricky. What is it expanding into? And more importantly, is there an edge to all this expansion? If you hopped in a spaceship and traveled in a straight line forever, would you eventually hit a wall, loop back to Earth, or just drift endlessly through infinite space? The answer isn't simple, but understanding it starts with grasping a few concepts that will absolutely blow your mind. The first step to solving this cosmic puzzle is figuring out whether the universe is infinite or finite. If it's infinite, it's not just big, it's beyond comprehension. It would mean that the universe goes on forever, with no boundaries, no edges, and, quite possibly, no sense of direction. But if it's finite, things get even weirder. A finite universe wouldn't necessarily have a hard edge like the wall of a room. Instead, it might loop back on itself, much like the surface of a sphere. Travel far enough in one direction, and you might find yourself back where you started. Does that sound insane? It should. But it's a real possibility backed by Einstein's theory of general relativity, which tells us that space and time are curved by the presence of mass and energy. There are three possibilities for the universe's shape. A closed universe. Think of it as a cosmic sphere. Travel far enough in one direction, and you'll loop back to where you started, like walking around the surface of Earth. An open universe. This would be like a saddle, stretching out infinitely and never looping back. A flat universe. This one is the cosmic equivalent of a blank sheet of paper, infinite yet non-repeating. The crazy part? The latest evidence suggests that our universe is flat. Not only that, but it's also expanding. And this is where things get tricky. To understand why this is such a big deal, we need to talk about the Hubble sphere. Imagine a bubble around Earth, 14.4 billion light years wide. This bubble contains everything we can see because light from these objects has had enough time to reach us since the universe began 13.8 billion years ago. But here's the kicker. Space is expanding, meaning objects beyond this sphere are moving away faster than the speed of light. Sounds impossible, right? Well, it's not the objects themselves moving, but the fabric of space stretching. Light emitted from these galaxies can never reach us, effectively putting them beyond our cosmic horizon. And it gets weirder. The observable universe is about 93 billion light years wide, much larger than the 13.8 billion years you might expect. Why? Because space has been expanding the whole time, dragging galaxies farther apart even as their light travels toward us. Why the universe ain't blindingly bright? This brings us to a paradox that has baffled scientists for centuries. Why is the night sky dark? If the universe were infinite and eternal, every single point in the night sky should be filled with light from a star. In other words, the sky should be as bright as the surface of the sun. This conundrum, known as Olber's paradox, has a mind-bending resolution. The answer lies in the universe's age and expansion. Because the universe is only 13.8 billion years old, there hasn't been enough time for light from distant stars to reach us. And because space itself is expanding, Some of that light is stretched into infrared wavelengths, invisible to the human eye. The result? A night sky sprinkled with stars, rather than a blinding glare. What lies beyond the observable universe? Here's where things get really wild. Just because we can't see beyond the observable universe doesn't mean there's nothing there. In fact, most scientists agree that the universe likely extends far beyond what we can observe, maybe even infinitely. But an infinite universe comes with some unsettling implications. If the cosmos truly stretches on forever, then every possible arrangement of matter must exist somewhere out there. That's right. Infinite copies of you, living out every conceivable version of your life. In one version, you decided not to click on this video. In another, you're the president of a galactic empire. And somewhere, far beyond our reach, there's a version of Earth where cats rule the world. These aren't just wild theories. They're the logical consequence of an infinite universe. And while it might sound like science fiction, the math checks out, though the idea of infinite copies of ourselves is enough to give anyone an existential crisis. Let's circle back to the shape of the universe. Using data from the cosmic microwave background, the faint glow left over from the Big Bang scientists have determined that space-time is flat. But what does that mean? In a flat universe, light travels in straight lines. Triangles add up to exactly 180 degrees. It's the cosmic equivalent of a perfectly level playing field. But here's the twist. A flat universe can still be either finite or infinite. If the universe is finite, it might exist on the surface of a higher dimensional shape, like a hypersphere. This would mean that while our local patch of space appears flat, it's actually part of a larger curved structure. Think of how the surface of Earth feels flat when you're standing on it, even though it's part of a sphere. But if the universe is truly infinite, it raises a haunting question. What happens to time, space, and reality itself? And then there's dark energy, the mysterious force driving the universe's expansion. Scientists estimate that dark energy makes up about 68% of the universe. Yet we have no idea what it actually is. What we do know is that dark energy is causing the universe to expand faster and faster. Left unchecked, this could lead to one of three terrifying scenarios. The Big Freeze. As the universe expands, galaxies drift farther apart, stars burn out, and the cosmos becomes a cold, dark void. The Big Rip dark energy accelerates to the point where it tears apart galaxies, stars, planets, and eventually even atoms. The Big Crunch. If dark energy reverses course, the universe could collapse back in on itself, triggering a fiery end. Each of these outcomes is mind-boggling in its own right, but they all share one thing in common. Humanity might not be around to witness them. So, what does it mean that scientists have solved the hardest problem in physics? On one hand, we've unlocked incredible insights into the nature of the universe. We understand its shape, its expansion, and its potential fate. But on the other hand, these answers raise even bigger questions. If the universe is infinite, are we just a tiny blip in an endless sea of possibilities? If dark energy continues its relentless expansion, what will happen to life as we know it? And perhaps the most unsettling question of all, if we ever find the edge of the universe, what's on the other side? All right, so now that your brain is sufficiently melted, what do you think? Are you comforted by the idea of an infinite universe? Or does it make you want to curl up in a corner and rethink existence? Let us know in the comments below. And hey, if you've made it this far, consider subscribing. Because while the universe might be infinite, your time isn't. So why not spend some of it exploring the biggest mysteries of existence with us?